1, Lesson 2, Data, Classification, and Levels of Measurement. Objectives. The students will be able to distinguish between qualitative data and quantitative data. The students will be able to find boundaries for a given measurement. The students will be able to classify data with respect to the 4 levels of measurement: nominal, ordinal, interval, and ratio. Terminology. A variable is a characteristic or attribute that can assume different values. Data are the values, either measurements or observations, that the variable can assume. Variables whose values are determined by chance are called random variables. A collection of data values forms a data set. Each value in the data set is called a data value or a datum. I usually don't use datum. I usually prefer data value. Qualitative data consist of attributes, labels, or non-numerical entries, whereas quantitative data consist of numerical measurements or counts. Example 1. The suggested retail prices of several Ford vehicles are shown in the table. Remember, this is old data. Which data are qualitative data and which are quantitative data? Explain your reasoning. So let's look at the table. First thing is quantitative. So we're looking at number of values, which would be this column right here. The suggested retail prices are quantitative because they're numerical entries. Qualitative data, on the other hand, is going to be the model. So the names of the models are qualitative data because they are non-numerical. More terminology. Quantitative variables can be classified into one of two groups: discrete or continuous. Discrete variables assume values that can be counted, like the number of pencils in my classroom. Continuous variables can assume values between any two specific values. They're obtained by measuring, like measuring an angle or the length of something. Classifying data. So here we have data, and first we can break it into qualitative or quantitative. But if it's quantitative, it can be broken down further into discrete or continuous. And you will need to be able to decide if data is qualitative or quantitative, discrete or continuous. But first of all, let's look at boundaries. Since continuous data can or must be measured, answers must be rounded due to the limits of the measuring device. Measures are usually rounded to the nearest given unit. So here's an example. A recorded height of 73 inches was rounded. It could mean any measure from what's the lower value? The highest lower value? No, the lowest lower value. That would round up to 73. That's 72.5 inches. Up to, but not including. So we need to think of the value that would actually round up to the next thing. Okay, that first value would be 73.5. So that would technically round up to 74, and that's why it's up to, but not including 73.5. So this is how we write it, and this is how we read it. We read it as 72.5 up to, but not including 73.5. So if you see boundaries written like that, that's how it should be read. So let's do a recorded length of 16 centimeters. So the lowest value that would round up is 15.5. 5 centimeters. And then it's up to but not including 16.5, because 16.5 technically would round up to 17. Okay, let's look at the next one, 89. So let's go down one and stick a half on it, and then stick a half on the other end. That's easy if they're whole numbers. It might be a little trickier if they're decimals. But with the decimal, pretend it's actually maybe 52. Because you know how to do whole numbers like the 16 and the 89. So with 52, you'd go to 51.5 and then stick the decimal on it. So it's 0.515, up to but not including 0.525 seconds. Do the same thing with the next one, except now we have the decimal at the end. So we're pretty much just working with that 7 like we would a whole number. So go down 2.65 up to but not including 2.75. Terminology review. We've seen these before. We'll see them again. A parameter is a numerical description of a population characteristic. They both start with a P. A statistic is a numerical description of a sample characteristic. They both start with S. Continue on. Measurement scales. This is the lowest level of measurement. It's the nominal level of measurement. It classifies data into mutually exclusive, which means non-overlapping, exhaustive, which means there's a category for everything that's possible. So they're exhaustive categories in which no order or ranking can be imposed on the data. No mathematical computations can be made at this level. It's qualitative data. Here's some examples. Eye color. There's no order to it. They listed them in some kind of order. It's not even alphabetical order. But there's no order or ranking to that. Those are qualitative. Gender. Zip codes. It's a numerical name for a geographic region. Lugoff is a zip code, 29078. We're just a numerical label for our region. Geographical region, nationality, political affiliation, and phone numbers, because you can't calculate with phone numbers. That is a numerical name for the location of your phone or how to get in touch with somebody. Next level of measurement, the next higher one, is ordinal level of measurement. It classifies data into categories, but these can be ranked. However, precise differences between the ranks do not exist. This data can be both qualitative or quantitative. Examples: your grade, A, B, C, or D. We do percentages, which is so much better. But if you're just getting a letter grade, an A can range from 90 to 100. Okay, so if we are comparing A's and B's, there isn't a precise difference between those ranks. Judging first place, second place, third place, so on, there isn't a specific or precise difference between the ranks. First place could have a much higher score than second place. It's just second is the next one down. Rating scales. Bad, poor, average, good, excellent. These are really tricky for me because how do you figure it out? Precise differences do not exist between the ranks. Motion Picture Association of America ratings. So how they rate movies. Those are categories. They are not ranked. There's not precise differences, they're just categories. Interval level of measurement ranks data, and precise differences between the units of measures do exist. However, a zero entry represents a position on a scale. It doesn't mean there's none of it. The entry is not an inherent zero. This is quantitative data. Examples: temperature. A temperature of 0 doesn't mean there's no heat, because you can actually go into the negatives for temperature. IQ scores, another example. SAT scores, another example. These are just examples. Now, the highest level of measurement is a ratio level of measurement. It includes quantitative data. It's similar to data at the interval level, with the added property that a zero entry is an inherent zero. A ratio of two data values can be formed so that one data value can be meaningfully expressed as a multiple of another. Let's say age. 1 year was really cool because my age was 4 times my youngest daughter's age. At the same time, my age was twice the age of my oldest daughter. I thought that was pretty cool. Back when I was 48. Think about their ages. Time. There's quite a difference between leaving my house at a certain time and leaving my house a little bit later to get to work. Time's going to be different. It could take me twice as long. It can take me 3 or 4 times as long to get out of the high school parking lot in the evening when traffic is so bad. Weights. Okay, let's not talk about that. Heights. Salary is an example. And snowfall. I know there's people looking for a snow day tomorrow. If not a full day, maybe a half day. But anyways, there's an example. We could get half an inch of snow, possibly, not saying it's happening, but the upstate could get 3 or 4 inches of snow. So there's definitely a ratio between those. Example 2, two data sets are shown. Which data set consists of data at the nominal level and which data set consists of data at the ordinal level? Explain your reasoning. So look at this. This is top 5 TV programs. Look at those dates. That was back in 2009, but it is a ranking. So there is an order to it. So that's going to be ordinal. Nominal is going to be that second set of data. It consists of all the call letters of each network affiliate in Pittsburgh. So the call letters are simply a name. So it's a qualitative data. It's at the nominal level. Ordinal, on the other hand, is the first set of data. It ranks the TV shows, so there is an order to it. Because the rankings, they may be listed in order, making them the ordinal level of measurement. But the difference between the ranks of 1 and 5 has no mathematical meaning. It's just a ranking. Identify levels of measurement. So let's look at the graph. It says identify the level of measurement of the data listed on the horizontal axis. So that's this one. So look at those. They are categorical and they look to be in order. So that is ordinal data. Next one. Still, we're looking at the horizontal axis, which is snowfall in inches, and that is ratio level of measurement. Horizontal axis once again, is the nominal level. And vertical axis is time, which is the number in millions. Don't like the way the graph is made. You should start your scale on the y-axis at 0. But motor vehicle accidents by year. So that is also ratio. Let's classify data. Here's some practice. We're going to classify data by type. We're going to determine whether it's qualitative or quantitative. So telephone numbers, you're not going to calculate with those. Those are qualitative. Body temperatures is quantitative. That's numerical. But the numbers mean something, whereas telephone numbers is a location to get to your phone. Lengths of songs is quantitative, but the number for each player on a soccer team, that's just kind of their ID. That is qualitative. Weights of infants at the hospital, numerical, so that's quantitative. Heights of hot air balloons is quantitative, but species of trees is qualitative data. Let's go on. Now we have the same kind of thing, but we're looking for determining whether they're discrete or continuous. So they are quantitative, and we got to identify it further. So body temperature of a patient is continuous. That's something that's measured. Like the length of his song is also continuous. Number of pencils in your backpack is countable, so that's discrete. We don't measure that, we count that. We can measure the length, but that's not what they're asking us. Number of assignments, that's countable, so that's discrete. A measure of time for your commute to school is continuous, that's measured. Height of a punt in a football game is also continuous, that's measured. And number of trees in your yard is countable, so that is discrete.